But one of the other details that we gloss over sometimes when we teach the biochemistry of this is the whole idea of where do the amino acids and tRNAs come from, right? We have these tRNAs that deliver an amino acid, but we gloss over the fact that to get a tRNA that has a specific amino acid attached to it, you've got to have an aminoacyl tRNA synthetase. In other words, we've got to have a whole other set of enzymes whose job it is to grab the appropriate tRNA and to pair it up with the appropriate amino acid. In other words, translation does not work if you randomly assort tRNAs with different amino acids. You've got to have a specific tRNA synthetase that grabs the right tRNA and pairs it with the right amino acid. That's a really, really critical thing. In fact, there are diseases, by the way, talk about inborn errors in metabolism, there are diseases that result from mutations in aminoacyl tRNA synthetases. So this is not an unheard of thing. What I want you to realize, though, is this was a big problem in the minds of some, at least, when they were trying to figure out how life could have originated naturalistically. Because this is a major issue, right? Going from DNA to RNA is simpler in concept than going from nucleic acid to amino acid. Because DNA and RNA, we've got this base pairing mechanism. It seems very elegant, but it also seems relatively simple in some sense. But to go from the DNA language to an amino acid language, that's wholly different altogether, because there's nothing inherent in the amino acid that specifies that it should pair up with that particular codon. That's why you've got to have the tRNA molecule itself. Hence the need for aminoacyl tRNA synthetases to grab the tRNA, pair it up with the right amino acid so that it can go off and do its job. Does that make sense to everybody? It's a very, very basic concept, but it's also very important to realize this is another barrier to the idea of this thing having developed naturalistically. And it was recognized as such. In fact, Francis Crick realized that there was going to be a need for such a thing, and he offered what was called the adapter hypothesis. He probably wasn't the only one, I don't know, proposing something like this, but he proposed what's known as the adapter hypothesis for going from RNA to protein. James Watson wrote this in response to that concept. He said, "I did not like the idea at all. More to the point, the adapter mechanism seemed to me too complicated to have ever evolved at the origin of life." And now it may go to explain why some of these guys believed in the idea of panspermia, that life originated somewhere out there and was planted here, right? Because some of them recognize on a biochemical level, there's a real high level of sophistication to this system as a whole that doesn't just originate by accident, doesn't just originate by chance. And so, here's a structure of a particular tRNA molecule. And so that gets grabbed by an enzyme and paired up with a specific amino acid so that you can have the translation process work properly. So this is what helps us translate RNA to protein, right? Without this molecule, and not just one, right? You've got to have several different versions, because remember, we've got these codon loops at the bottom, 3 nucleotide sequences. So there's 64 possible combinations there. And you've got to have those to bring things together.